Hi, Assalamualaikum. My name is NURUL SYAZANA binti Muhammad SIDEK and my matric number is A2182955. So today we will talk about our report.
Hello everyone, my name is ERRIFIONARANI JAMARI and my matrix number is 81A2458. Today I will present about data description and numerical descriptive measures. Data is collection of any number of related observations. The interpretation of data refers to the explanation of the meaning of the data. A data set is a collection of data that is typically present in the form of a table. Each column represents a specific variable. In statistics, the data set usually comes from the sample statistical population obtained from actual observation, and each row corresponds to a component of the observation, the population. The data set may generate algorithms for certain kinds of software for testing purposes. Some modern statistical analysis software, such as SPSS, helps us to analyze the chosen dataset. We decided to select 92 out of 160 random cases based on the highest matrix, the number of members of our group. This is the table of weight and height. That's the random 92 out of 160 cases.
Hello doctor, my name is ESTENSIA and my metric numbers is 81824559. For my part, I will present about sampling data and record categorical data. So I will start with sampling data first. What is sampling data? It is a statistical analysis technique that involves selecting, manipulating, and analyzing a sufficient to establish all variables in order to identify patterns and trends in the larger dataset under consideration. And sampling may be especially beneficial with datasets that are too vast to fully evaluate, such as in big data analytic application or servers. Choosing and analyzing a representative sample is more efficient and cost-effective than surveying the complete dataset or population. Sampling can be based on probability, which is a method of ensuring that there is no association between the points picked for the sample by using random values that match to points in the data collection. Okay, there's some types of data sampling. It is simple random, systematic, stratified, cluster, and multi-stage. Okay, now I will go to the next one, categorical data. Categorical data is a collection of information split into categories. Okay, the resulting data is referred as categorical. Types of categorical data are nominal and ordinal data that our group use. Sample size refers to the number of participants or observations. This number is usually represented by the size of sample influence two statistical properties. Our group, we use the lowest last two-digit number of our group member metric number as our sample size of this observation, which is 60. We are used the lowest two-digit number of metric number of the student named SYLVIENIE SUIN, which is 81A3132.
Now, let's move to the numerical descriptive measures. There are three types of numerical descriptive measures. That's it. Measures of central tendency, measures of position, and measures of variation. A measure of central tendencies is a single value that represents the central of a distribution. There are three most used measures of this tendency for ungrouped and grouped data, namely mean, median, and mode. The mean is the sum of value of each observation in a dataset divided by the number of observations. On the other hand, the mean is the average of a data set, and it is also known as the arithmetic average. Next is median. The median is the middle number in a sort, ascending or descending list of numbers and can be more descriptive of that data set than the average, and the mode is the value that appears more frequently in a data set. This is the mean, median, and mode that we obtain from the data set with two different variables, namely height and weight. Next is measures of position. A measures of position determines the position of a single value in relation to other values in a sample or a population dataset. Unlike the mean and the standard deviation, descriptive measures based on the quantiles are not sensitive to the influence of a few extreme observations. For this reason, descriptive measures based on quantiles are often preferred over those based on the mean and standard deviation. A quartile is one of 3 points that divide a dataset into 4 equal groups: first quartile, second quartile, and third quartile. This is the quartile that we obtain from the dataset. Now, let's move to measures of variation. A measures of central tendency is some parameters that attempt to describe the amount of variation between random variables. There are 3 parameters that are used commonly to quantify the amount of variation in a set of random variables, that are range, variance, and standard deviation. The range is the difference between the lowest and highest value. The variance is mean squared, difference between each data point, and the center of the distribution measured by the mean. The standard deviation is the statistic that measures the dispersion of a dataset relative to its mean and is calculated as the square root of the variance. This is the range, variance, and the standard deviation for weight and height in the dataset.
Next, I will continue with presenting graphical representation. So, the use of intuitive chart to visualize and simplify datasets is referred to as graphic representation. Data is entered into graphing software and then represented by symbols such as lines in a line chart, bars in bar chart, and slices in a pie chart. Furthermore, since these are quantitative variables, they can be represented by a scatter plot, histogram, frequency, polygon, or a GIF. To represent the height and weight of fish in this section, we will use a line graph and a histogram. So I will start with histogram first. You can look here in my slide. I put a histogram graph and the table. The table where it have a class, midpoint, and frequency that I use to build a graph, histogram graph. I also provide the formula that I use to get the midpoint, which is lower boundaries add by higher boundaries, then divide by 2. From the histogram, we can see that the graph level is X with midpoint, so that the graph starts with the first class with the midpoint at 100.5, where the frequency is 39, and ends in the last class with the midpoint at 1300.5, where the frequency is 1. Therefore, we can conclude that the highest weight of fish are between 1 to 200 because it is the highest frequency compared with other classes. So we will go to the next one. I choose the next graph is line graph. So here in this slide you can see the graph and the table, also the formula. Okay, the table we have class, midpoint, frequency, and cumulative frequency. From the line graph, we can see that the graph starts at 2, where the cumulative frequency is 11, and the graph ends at 14, where the cumulative frequency is 6. From this, we can conclude that the most highest height of fish is from 5 to 9. Okay, that's all from me. Thank you.
Hello, my name is SYLVIENIE SUIN, number matrix 821-83132. Now I will present for statistical analysis using Excel and SPSS. Microsoft Excel has the basic feature of all spreadsheet using a grid of cells arranged in numbered row and letter name column to organize data, manipulations like arithmetic operations. It has a battery of supply functions to answer statistical. Second, SPSS, Statistical Package for the Social Science. SPSS provides data analysis for descriptive and statistic, numerical outcome, predictions, and group identifications. Next, we go to the numerical descriptive measure. Let you see this. This is the calculating manually and calculating by Excel. For calculating manually for mean, range, minimum, maximum, quartile 1 and quartile 3 show the same value like the calculating by Excel. But for the median, mode, standard deviations, and variance are not same. For example, like mode, the weight mode is 132.7 and the calculating by Excel weight is also 132.7. But for the height, the mode is 7.865 and the height for mode calculating by Excel is 9.980. This is not same. The difference between is 2.115. Next, draw graph by using Excel software. The first graph is weight. From the above graph, we can see that the x-axis represents the frequency and the y-axis represents the midpoint for the weight group. The midpoint must calculate for each class to get the midpoint answer. After calculating the midpoint, each midpoint must be compared to the frequency of each class. The total frequency must be equal to the sample size, which is 92 of the dataset. And for the height, the line graph, from the above graph, we can see that the x-axis represents the frequency and the y-axis is midpoint for the height group. The first point must be at the 11 frequency with a midpoint 2. The last point must be at 14 frequency with a midpoint of 13.
Assalamualaikum, my name is Maisarah binti Rameli and my metric number is 818872. Next, hypothesis testing. Hypothesis is a proposition, statement, or assumption based on some previous observation about the value of a population parameter for testing purpose. While hypothesis testing is a process based on some sample data and probability theory to conclude whether the hypothesis is reasonable and should not be rejected or otherwise rejected. To test the validity of the assumption, we must select a sample from the population, calculate the sample statistic, and based on certain decision rules, accept or reject the hypothesis. Next, to test. There are 5 steps in the test, which is state null hypothesis and alternate hypothesis, state the level of significance, compute the statistics or SPSS output, decision rule, and lastly, making a decision and forming a conclusion. For the test, we have made a decision that we reject hash null since negative 3.161 is less than 2.074. Therefore, we can conclude that the two population means are not equal or there is a significant difference between the two population means. Next, ANOVA. The factor that has been chosen is species. The p-value from the ANOVA table is less than 0.001, which means that at least one of 7 variables, which is price, weight, length 1, length 2, length 3, height, and width can be used for model species. ANOVA for price. We have made a decision that we reject hash null since 14.984 is more than 2.21 and conclude that there is a significant difference among the treatment means. ANOVA for weight. Have concluded that we reject hash null since 12.885 is more than 2.21 and conclude that there is a significant difference among the treatment means.
Next, we go to the correlation analysis. Correlation. Correlation is a statistical technique used to determine the degree to which two variables are related in statistics. The word correlations refers to the relationship between the two variables. Perform correlations analysis using the variables of interest. Step 1 is hypothesis. Step 2 is significant level. And the step 3 is Excel output. And step 4 is decision rule. And lastly is step 5 is decisions. So we reject hash null because 2.8 more than 0.05. Thus, we can conclude there is a correlation between weight and height. It's a strong positive correlation.
Confidence interval. Confidence interval is a range of value within which the population parameter is expected to occur. The 95% confidence interval can be related confidence level. The lower boundaries and upper boundaries for constant are 9.679 and 29.572. The lower difference between lower and upper is 19.893. The lower boundaries and upper boundaries for weight are 866 and 907. The difference between lower and upper is 41. We are 95% confident that the dependent variable is price.
Prediction modeling. Multiple linear regression allows us to use several variables at once to explain the variation in a continuous dependent variable. Besides that, it allows us to isolate the unique effect of one variable on the continuous dependent variable while taking into consideration that other variables are affecting it too. Firstly, scatter plot. In the scatter plot matrix, graph 1 plots weight against price. It is seen that the higher the weight, the higher is the price of the fish. Graph 2 plots weight against species group. Generally, the graph shows a positive weight correlation. Graph 3 plots price against species group. Generally, the good or high quality species of fish, the higher is the price. Secondly, correlations. The R values between species group and weight is 0.600, price and weight is 0.994. Thus, weight is associated with both species group and price. The R value between species group and price is 0.628, which is less than 0.85. Perhaps there is no problem of multicollinearity. Thirdly, test of normality. The Shapiro weight test of normality on the species group, price and weight gives a p-value of 0.000, which is less than 0.05. Thus, the assumption of normality of this is not met. Next, model summary. The R-square value is 0.444, which means 34.4% of the variation in species group can be explained by weight and price. Next, ANOVA. The p-value from the ANOVA table is less than 0.001, which means that at least one of the two variables, which is weight and price, can be used to model price. Lastly, coefficients. The equation is y equal to b naught plus b1x1 plus b2x2 plus b3x3. So, species group equal to 2.334 plus 0.018 minus 0.013. Thus, for every unit increase in price, the species group will go up by 0.018, provided the weight of fish is still the same. Similarly, for every unit increase in weight, species group will drop by 0.013 units, provided the price of the fish remains unchanged. The 95% confidence interval for price is 0.008, 0.028, where the value of 0 falls within the interval, again indicating price is not a significant predictor. Whereas the 95% confidence interval for weight is negative 0.022, negative 0.004, where the value of 0 does not fall within the interval, again indicating weight is a significant predictor.
In conclusion, statistics is a branch of mathematics that deals with analyzing, summarizing, and interpreting a group of data, large-scale data collection and analysis for the purpose of extrapolating general population proportion from a representative sample are the focus of this course. Descriptive statistics and interferential statistics are the most common types of statistical analysis. The organization, summarization, and presentation of data are all part of descriptive statistics. Tables and graphs are used to display the information. Simple terms are used to describe the data's characteristics. In the meantime, inferential statistics entails making generalizations about a population based on the result of a sample. A population is often made up of the large number of people who share a common characteristic. It is possible to perform descriptive statistics such as mean, mode, and median using the data that has been gathered and analyzed in this way. Other than that, use the appropriate table to describe and explain the secondary data. This study also aimed to calculate and interpret the measures of central tendency, variation, and position for the secondary dataset. So, in this report, we can know about the data and how it was collected, how it was analyzed, and how it was interpreted using statistical software and theoretical models based on the data's population.